All right, yesterday we started off section 141. So we started off section 4.1. So we'll call that A, even though I didn't write down A yesterday. But we'll call today B, since it's the second part. Hopefully we'll be able to finish today. I'm not going to review yesterday, but just remember how to label the types of triangles, okay, by their sides and by their angles. And that's enough of that. Let's find me a good triangle here. See, I got some triangles. Let's use this one. Doesn't really matter for what we're doing right here. I could use any of them, but I'm going to use this one. Just kind of looks like the one that's in the book. That's why I picked it. Let's scooch this over a little bit. Come on. Come on. There it goes. All right, what I'm going to do now is I'm going to take this triangle and I'm going to actually extend one of the sides. So let me do this. Let's see if actually it's not ungrouped, so I'll just have to make another line. Let's just do this. I'm going to take this side right here and I'm just going to extend it out like that. Okay? So it's just a triangle with one of these sides extended out a little bit, and it makes another angle here, doesn't it? Everybody see that? So what I want to do first, before I talk about this, I want to talk about a couple of these angles. Well, three of these angles in particular. This angle right here, do you see this one right here? That's on the outside of the triangle. It's not actually in the triangle, is it? If I extend one of the sides. So if it's not in the triangle, it's not an interior angle. What do we think? What do you think we're going to call it? Right. And we've used that word before with something else. Okay, this would be considered an exterior angle. What about the angles inside the triangle? What would I call those? I call them interior angles, okay? But I'm going to specifically look at two particular angles. This one right here and this one right here, okay? If you look at this exterior angle, these two interior angles are further away from that exterior than this one. I got a lot of people looking around. You've got to watch because I'm pointing to stuff over here and you're not watching, so you're not going to know what I'm talking about. So everybody look at the screen, please. Got this exterior angle right here. This interior angle and this interior angle are further away from this exterior than this angle right here. Do you see it? This one's right next to it. And in fact, let's just put two arcs right there. See this angle and this angle? They're right next to each other. We're going to talk about this another time. I don't know. It could be in this chapter. I can't remember. But we would call these adjacent angles because they're right next to each other. Right? They form that straight line. See how this angle and this angle right next door to each other? So we call them adjacent. We're going to use that word quite a bit throughout the rest of the year. But these are not adjacent. These are away. They're farther away from that exterior angle than this adjacent angle is. So we call these the remote. Because remote means you're kind of far away. Like I go hiking, people say, well, my friends don't call me Mr. Hamrick. I was about to say Mr. Hamrick, but my friends say, Aaron, I can't believe that you're out in these remote parts of the forest. Well, I'm really not too much in the remote areas, but what are they saying? That means I'm away from stuff, right? I'm away from civilization. Okay, the remote control that you use for your TV, it's because you're away from the TV. Back in the day, actually when I was your age, even in high school, I didn't even have a remote control to the TV. Guess what our parents used to make us do when I was a kid? If they wanted to change a channel, they would say, Aaron, get up, change channel, channel 10, channel 6, or whatever. We only had like 4 channels back then. Can you believe how old I am? It's amazing. We had 3, 6, and 10. We had channel 12. And then actually we probably had a few more. We had some VHF channels, which you don't even understand what that means probably. We had channel 17, channel 29, and channel 48. And that was it. So what's that? Like 7 channels altogether? That's all the channels that we had. So I would have to get up and go to the TV. So why do we call it a remote control? Because we're what? We're far away, right, from the TV. You make sense? So these remote interior angles are farther away from the exterior angle than this angle right here. You see it? You got to know these words first because we're going to give like a little definition here, a little theorem, and we're going to use the word exterior angle and remote interior angles. So let's just finish it up. I'll just shorten it. I'll just put INT. Okay, the remote interior angles. All right, so just know what they are, because right now we're going to have a theorem that talks about the relationship between the exterior angle and the remote interior angles. Okay, so let's do it. I'm just going to, let's just write it out. In fact, let's see. I'll type it. Oops, that's a mess, isn't it? There we go. And it's in black, so that doesn't show up too well, does it, since I have a black background? So let's do that. There we go. Oh, I don't like that either. Oh, I know what we need to do. We need to do this. Hold up. Give me a sec. Give me a sec. Let's see if that works. Oh, that's still terrible. All right, I know what I'm going to do now. Hold on. Should have done this at the beginning. Could have just written it out, couldn't I? Let's just take... Oh, let's just write it out, for goodness sakes. I'm trying to be fancy, and it's just taking longer than I wanted to. So let's just write the thing out. But my handwriting's so terrible. But that's okay. All right. Here's what it says. Oh, I got to go change it back to white. All right, so this is called the triangle. Write it down. It's called the triangle dash angle sum theorem. Okay, what does the word sum mean when we're talking about math? Okay, it's addition. Okay, so we're going to add a couple things together, right? And we're going to talk about a triangle, which we have right here, and we're going to talk about some of the angles inside the triangle. So here's what our theorem says. It says the sum of the measures, write this down. This is an important one to write down. I don't always write down every single theorem, but I think this one's important. The sum of the measures of the angles. Actually, you know what? I did that whole remote thing. We're not doing that to the end. What am I thinking? I was looking at this picture that I drew here, and for some reason I was thinking we were going to do that remote thing. We will get to it, all right? Don't worry. So, sorry about that. Let's just change let's change this a little bit. So the sum of the measures of any triangle, but this is still important. This is super important. Of any triangle is, now you probably already know this from doing some from math classes in your past. You might have learned this even in elementary school. The sum of the measures of, I'm just not on it today. Is it because it's Friday? Of the, oh my word, sorry about this. It's probably, I'll blame it on Friday. The sum of the angles of any triangle, there we go. Now, if I could just read my writing, of any triangle is, and I'll just put what it is right here. Now, the sum, what does that mean? We're going to add up what? We're going to add the measures of the angles, of all three angles of a triangle. So if I have a triangle and I add up all three angles inside that triangle, it's always going to come out to be one particular number. Did you learn this back in elementary? It's 180 degrees, okay? You probably learned that before, haven't you? You've never learned that. You've never learned that the angles in a triangle? Did I tell you? Okay. And I might have said that later on we're going to talk about it some more. Well, here it is. It's later on. And we're going to that fly is driving me crazy too. I'll keep swatting at it. So this is very, very important. So let's see. Did I still copy that? Yeah. So let's take a look at this. Here's just a triangle. Kind of looks like that triangle we did before, or I could flip it like that just to make it look a little different. Okay. So if I add it up, I'll tell you what, I'm going to show you why this is true. Now it's around me. Get away from it. So I'm going to show you why it's true. Let's see. I'm going to draw a straight line, and I'm going to make it hit right there. And I think I can make that dotted. Oh, there's no dotted lines here. Maybe this shows me. Nope. Well, shoot. How do I get a dotted line? Well, that's all right. I'm just going to do that. I won't be dotted. I'll just change the color of it, okay? Usually I put a dotted line, but it doesn't make any difference. Now, watch what I want to do. I am going to do this. I'm going to name some of these angles. We'll call this angles 1, 2, and 3, all right? So according to this theorem, now remember, what's the difference between a postulate and a theorem? A theorem can be what?
True or false?
No, they're all true. It can be proven. It can be proven, okay? So what we're going to do, I'm not going to do a formal proof because I'm really not going to do that in here. But what I'm going to do is I'm going to talk you through it. So this is basically a proof, all right? So if you ever hear people talk about doing proofs in geometry, this is a proof. I'm going to name this angle as well. I'm going to call this angle 4, and I'm going to call this angle 5, all right? Now, we have learned this. If you have angles that form a straight line, how many degrees does that equal? 180. Do you agree? All right. Anytime you have a straight line and I have an angle like this angle right here, x, and this angle y, what does x plus y equal? 180 degrees. Okay. Any angles that form a straight line, excuse me, equals 180. So tell me something about 4, 2, and 5. Say it.
They are the the adjacent angles.
Yeah, but what did I just say right here? Follow my train of thought. Yeah, follow my train of thought. I said that x and y make a straight line, so they add up to 180, right? So I'm trying to get you to get somewhere, okay? I know, I heard it already. I was working with him, okay? I don't even know if there's a sharpener. It's not my room, so I don't know. All right, so see, you broke my train of thought, okay? Take care of that on your own. I'm in the middle of saying something right here. So if x plus y equals 180, tell me something about 4, 2, and 5. They add up to 180, right? Okay, again, follow my train of thought. I said if those two add up to 180, then these three add up to what? 180, okay? And it is true. You are right. You're not wrong saying they're supplementary, but I just want you to follow my train of thought. So let's write that down. Angle 4 plus angle 2 plus angle 5 equals 180, okay? Now, see this red line right there? I drew that red line specifically so that it's parallel to this line down here. So how could I show that? Put a little arrow here and a little arrow here. So now what we're going to do is now we're going to go back to the other chapter that we just finished. Was it, maybe it was the first chapter. I can't remember what chapter. Anyway, didn't you have a test on this stuff? Yeah. So tell me something about some of these angles. If this is a parallel line to this line right here, tell me something about 1 and 4. Let's get somebody else. Somebody tell me. All right, Braden. Why are they equal? Give me a reason. 1 and 4 are what? What's the name of those angles that they're equal to? What? Are they exterior? Are they outside the parallel lines? No, they're inside, so they're interior. So 1 and 4 are alternate interior angles. So they're equal to each other. Let's mark it on our picture. You see that? So 1 and 4 are equal to each other. So let's go down to here. And what are we trying to show anyway? We're trying to show that angles 1, 2, and 3 add up to 180, right? Okay. So we know 4, 2, and 5 add up to 180 because it's a straight line, right? Because they form a straight line. A straight line's 180. Everybody good? We know 1 and 4 are equal to each other because if these two lines are parallel, then 1 and 4 are equal because of alternate interior angles. So instead of writing angle 4, what could I write? What's equal to angle 4? Angle 1. You with me on that? Okay. So I could replace angle 4 with angle 1 because they're the same. They're equal to each other. You with me?
Yeah.
All right. What else can you do? Very similar to what we just did here. What else can you do? You can do that with the 3 and 5. So let's put 2 arcs there because that doesn't, if I put 1 arc, that means 1 and 2 or 1 and 3 are equal, but I don't know that 1 and 3 are equal. So I'll put 2 arcs. So 3 and 5 are equal. So now I can come down to this little equation and do what to it? Replace angle 5 with what? Angle 3. Now check this out. I really don't know anything specifically about angle 2, but I could just write down angle 2. And look what we just did. We just proved what? That theorem, that the 3 interior angles, the 3 angles of the triangle, add up to 180. Okay? And that's why it's true. They probably never showed you that when you're in elementary or middle school or whatever, when they first told you that the angles add up to 180. They just told you, you believed it. You know, it's a teacher. You believe everything they say, right? So now you don't have to, because I just proved it to you. Okay? We proved it together that the sum of the angles of a triangle are 180 degrees. All right, enough of that. Let's do this.
You just need to find the consecutive or alternate interior, and then you can figure out.
Yeah, you had to know those two lines are parallel, okay? And then you could say that that 1 and 3 or whatever angles I said they were, 1 and 4 were equal and 3 and 5 are equal, okay? And then with that, so 4 and 1 are the same. So anyway, we did this. We said that was 180, right? So this is 1, this is 3, right? 1, 2, and 3 add up to 180. So 1, 2, and 3 add up to 180. You get the idea. All right, enough of that. Let's do another one. Let's do a little offshoot of this theorem. Sometimes they call those little offshoots, they call it a corollary. I don't know if I've said that before in here. Okay, it's a corollary. Okay, what it means is it relates to the theorem that we just did. It doesn't say the exact same thing, but it has to do with that theorem that we just did. Okay, and let me grab this triangle right here. What does that triangle look like? Yeah. Now, we don't know for sure it's a right triangle, do we?
No, we don't, because it has right angles.
Right, but it is.
Yeah.
And I'll put a little right angle. Now it's a right triangle, okay? All right. So here's what the corollary says. The corollary, since I wrote that in blue, let's write the corollary in blue. So I just got a right triangle so you can look at it. It says the acute angles, I'll just shorten it, the acute angles of a right triangle, and I'm going to shorten right. Braden, right here. Of a right triangle are complementary. Now, I haven't used that word before, but it sounds like something else that we have used before, and we actually said it in here. It sounds like supplementary, doesn't it? So supplementary means what? It means the two angles, or any number of angles. It doesn't have to be just two. But, right, the angles add up to 180. So what do you think? It's a big hint, because I got a right triangle right here. What do you think it means when angles are complementary?
90 degrees.
They make 90 degrees. That's right. So the word complementary means angles that add up to be 90 degrees. Supplementary, they add up to be 180. Complementary, they add up to 90. So what does this corollary right here say? It says the acute angles. What does that mean, the acute angles? Well, that's a right angle. So what angle must this be? This must be an acute angle. And this one right here has got to be an acute angle. Okay? Is it not necessarily? Is that what you said? Oh, it's not necessarily 45. No. Okay? It's not. All right? This could be 30. This could be 60. This could be 20. This could be 70. All right? It doesn't have to be both 45. All right? But what does this say, though? But they are both acute. They're both less than 90. All right? So what's true about those angles? They must be what? Complementary. So if I call this, let me use the same letters I used in my notes, ABC. So what is this corollary basically telling you then? It says the acute angles. Which angles? I've labeled them now. Which angles are acute? Which ones? B and C. So that means that angle B plus angle what? C equals what? 90 degrees. All right? And it should make sense, because how much is this? It's 90 degrees. So these two have to add up to be what? 90 degrees, because all three of them add up to be what? 180. Does that make sense? Do you see how it's a corollary, it's an offshoot of that theorem that we just did? Right, because it has to do with angles adding up to be 180. And that's what we have here. These three angles add up to 180. We know if we have a right triangle, we have a right angle. That's 90. So 180 minus 90 is 90. So this and this have to add up to 90. Every single right angle or right triangle, that's true for. Everybody got it? Yep. Okay, so if I gave you an example and I said angle C was, I don't know, let's make it easy. Let's say 20 degrees. very, very quickly, you should be able to find angle B. It's 70. What's the math? You just went 90 minus 20. You with me on that? Now, they're eventually going to do stuff like this. Now, I don't know if this, I'm just making this up off the top of my head, okay? So I don't know if this number is going to come out. But what if I said that this was like 3x minus 2 and this was 5x plus 7? Again, I don't know if these numbers are probably going to come out weird, so don't even do it. But what could I do? How could I set it up to solve for x?
3x minus 2 plus 5x plus 7 equals 30.
That's exactly right. Okay, I would take those two together, all right? Now again, I don't know if this is going to work out pretty or not. I'm going to add them up. So if I add those two angles together, what should they add up to be? 90 degrees. And then what could I do with this? I could solve for it, do my algebra, right? Solve for x. And then if I wanted to find out what that angle actually is, I could take x and do what to it? Just plug it back in. Make sense? We're going to do stuff like that in here, all right? The rest of the year we do stuff like this. You see how that's not much different than what we did in the last chapter? Except we're doing it with triangles now, all right? We look at the picture, we learn some stuff about it, we write down an algebra formula, we solve for x, we plug it back in, all right? That basically sums up geometry. There's a lot more to it, but that's a lot of it. Okay, that's one of the corollaries. You have a second corollary, all right? So you have another one. Again, a corollary is kind of like a theorem. You can prove it, all right? It is a theorem, but it's just an offshoot of like the bigger general theorem. And this one says each angle, all right, so each angle of, here's a word that we did just the other day, equiangular. We did that yesterday, I think, didn't we?
Yeah. When all sides are the same, right?
Yeah, well, equiangular is not, it's angles, right? Has a measure of, oh, did we not do equiangular? Okay. Yeah, so, but it's just, that's common sense though, right? If equilateral means all the sides are equal, then equiangular means all the angles are equal, right? Okay, even if we didn't talk about it, that should make sense. I tell you what, I'm not even going to tell you what it is. I mean, you might have your book open, you might see it, but let's see. I think I might have, yeah, I do. Look at that. I happen to have an equiangular triangle right here. How about that? That's right. Okay, but let's figure it out before we actually let them tell us. Now, if all these angles are equal, okay, so this angle, we'll call it x, and this angle is x, and this angle is x. Why didn't I call it like x, y, and z? Because it's what kind of a triangle? It's equiangular, so they're all going to be the same exact letter, right? Because they're all the same value. Make sense? All right, so what do all three of these do according to that theorem? They add up to 180. So what's x plus x plus x?
180.
It's 3x. Okay, x plus x plus x is 3x, and that equals what? 180. You understand why I got 3x? X plus x plus x. I just added up all three angles. That's exact. Well, you divide by 3, and what's x? It's 60 degrees. So let's finish up this corollary. So each angle of an equiangular triangle has a measure of what? 60 degrees. And what we did right there was basically a proof. All right? It wasn't a formal proof, but that's okay. We basically proved why that's true. All right? That's pretty good. All right. Let's do another one. Now we're going to another theorem, completely different theorem. So let's go, I don't know, what color can you read? Can you read this? Oops. There we go. Can you read that? Yeah, that looks all right. Okay, so here's a theorem. Write it down. I'm not even, if you look in the book, they actually like number the theorems. They call it like 4-1 something. I don't know. There's every book numbers theorems differently. So I never ever remember like the name of the theorem according to what the book calls it, okay? So if it's like 4-1-3 or something like that, I don't know. Is it written? Anybody got their book open? So what's that next theorem says? It says if two angles. Anybody know the name of it? Look at it. It says, if two angles of one triangle, what's the theorem number on it? Look at it. It's in the book. It's right there. 4.1.2? Right. It's 4.1. Why do you think it's 4.1? Because it's chapter 4, section 1. It's 0.2 because it's our second theorem, okay?
Is that why you don't ever make this?
Yeah, there's no way I'm going to make you memorize this, because if you learn these theorems in another book, this might not be in chapter 4. It might be in chapter 3. It might be in chapter 5, okay? So this is not like a universal number for this theorem, all right? We're just going to know what it says. So if two angles, let me put this up here so I can read it. So if two angles, write this down, shouldn't be talking if you're writing this down, of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. I'll just put congruent. Or you could say equals. I'm fine. Again, like I said yesterday, a lot of teachers have a real problem with saying equal with triangles instead of congruent. I get why they say that. I completely understand, but you could say equal. I don't really care. All right? So anyway, but triangles technically are congruent to each other, okay? So I think if we say that, but when we talk about angles, anyway, let's just do this. If two angles of one triangle are congruent to two angles of another triangle, well, let's get a couple, I'm going to go way back up here. Let's just grab some random triangle. This one right here. Let's scooch back down. I'll keep that there. All right, now watch what I'm going to do. I'm going to move this, copy and paste, move it right there. Now in the book, they kind of flip them around. I'm just going to make it super easy for you and just keep them the same, orientation and all that kind of stuff. But if I call this A, B, C, and I call this X, Y, Z, X, Y, Z, what's it say? It says if two angles of one triangle, okay, so two angles over here, if they show you that they're congruent to two angles of another triangle. So for instance, let's say they told you, now we don't know this unless they tell us, okay? So if they told us angle A was equal to angle X, and if they told us that angle B was equal to angle Y, this theorem says what must be true about C and Z? They're equal to each other. And then why would that be true? Because you're taking them both away from what? Because look at this. Angle A plus angle B plus angle C is equal to what?
Angle X.
No. A, B, and C. I know for a fact that they're equal to what? Say it. 180. Okay. Now, over here, I know that angle X plus angle Y plus angle Z is also equal to what? 180. Now, watch this. If I know that A and X are exactly the same, so let's do this. Let's replace this with angle A. Because they told us, right? They told us they were the same. What else did they tell us? B and Y were equal to each other. So instead of angle Y, I'm going to call it what? Angle B. And this is 180. Actually, you know what? Oh, I messed this up. It's not exactly what I wanted to do here. Let's get rid of slashing those out. Okay, let's do this. Sorry about that. Now I got it. They're both equal to 180, so they both have to equal each other. Would you agree? Oops. Angle Y plus. Again, we're doing a proof. This is basically a proof, all right? So now, what did we say about A and X? They're what? They're equal to each other. Now in math, in algebra, if you have something on one side and the same thing on the other side, can't you just subtract them both and they go away? No. You can't? Sure you can. Okay? Because watch. 3x plus 2 equals 2. What can I do? I could subtract a 2 and they both go away, don't they? Okay, what about this? If angle A and angle X are equal to each other, what do? They cancel each other out, don't they? Okay, if B and Y are equal to each other, what do? Cancel out. So what are we left with? What are we left with? No, listen, we don't know anything about C and Z. Shh. Come on now. We don't know anything about C and Z, all right? So we can't say they cancel out, but since these cancel and these cancel, what are we left with? We're left with angle C equaling angle Z, all right? So what does that mean? That means if I know that one angle over here is equal to one angle over here, if I know a second angle on this left triangle is equal to a second angle on this right triangle, what can I now say about C and about Z? They have to equal each other, okay? And that's going to come in handy. Again, they're going to put stuff. Sometimes they'll just put numbers in there. Sometimes they'll put letters like 3x plus 2 and 5x minus 7 or something like that. And you got to do stuff with that, all right? But this is the main idea of what's going on, all right? So let's finish. We got 5 minutes. Let's finish with, yeah, because I don't think we're going to be able to. You know that thing we started with? I wasted, the remote interior angles. We are not going to get to that, but that's okay. Let's do this. Let me come way up here again. Let's grab a triangle. Let's grab this one. All right, scooch all the way back down again. All right, put it here. And let's do this. And let's flip it around. Let's see, I'm trying to make it look like, I think I can flip this like this. Yeah, now it's starting to kind of look like what's in the book. It's not really looking like I want it to. There. Guys, why are we talk about this all the time. Just because I take a couple minutes just to try to draw something, I am not doing a good job at this. I should have just... Is that what it is? It's Friday? Okay. I want to go like... Let's see if this will stretch out. Okay, I'm starting to get it. Oh, hold up. There we go. Now it kind of looks like the one in the book. That's all I was trying to do, is trying to get it to look like the one in the book. All right. Spent way too much time on that. Let's do this. Let's take it about like right there. All right. Let's put some numbers in here. Let's say, so this is an example. All right. It's not a new theorem. This is just taking what we've learned so far and trying to figure some stuff out. That's 45 degrees right there. Okay. And what we're going to have to do is we're going to solve for angle 1, we're going to solve for angle 2, and we're going to solve for angle 3 using the information that we've learned today. All right, what's the easiest one to solve for right now? It's angle 1, that's right. So I've got 36 and 60. How in the world do I find angle 1? That's right. Yeah, it's 180 minus, can you do this in your head? Yeah, 96. Everybody see where we got 96? I just added 36 and 60. And that's 84 degrees. So angle 1 right here is 84 degrees. What do you think the next one we can do? You could do 3 right away if you wanted to, but I'm going to do 2. What's a real easy way to find angle 2? Again, there's a couple ways you could do it.
2 and 60,
You don't have parallel lines. You can't say alternate interior angles. Look at it. You know 1 now. You know 1. Yeah, 1 and 2, they form a 180-degree angle, don't they? They form a straight line. So what could you do? Right, you go 180 minus 84, which gives you 96. Or what we learned today, this, if I extend this side, this right here is an exterior angle, and these are my 2 remote interior angles. Do you see that? So what's even easier... Right? Forget the 3, forget the 45, okay? And forget that line right there. Just look at the triangle. We extended one of the sides, so angle 2 is an exterior angle. It's outside of this triangle. What did we learn about that? It's equal to the sum of the remote interior angles. So really all I have to do is go 36 and 60, which is 96. Okay? You with me on that? What about angle 3? What can we do with that? Well, we know this is 96. We know this is 45. So 96 and 45 is what? 1141? 41? Okay. So these two add up to 141. How do I find angle 3 then? Subtract from 180. So it's 180 minus 141 is 39 degrees. So now I know angle 3 is 39 degrees.
So just figure out the other two angles of the triangle and then you can subtract and you'll get that.
Yeah, that's how you can get angle 3. If you know angle 2, right, you can take those two because these 3 add up to 180, right? And there you go. So that's kind of cool. I like that. All right, what I'm going to do, there may be some problems on here that you won't be able to do, but I want you to get started at least, okay? So here's your homework. Again, there might be some of these that you can't do with that. Oh, actually, you know what? I taught that remote interior thing, but they have not taught it as of yet. So this 2 right here, you would get it by 180 minus 84, right, to get that. Because I really haven't technically taught it to you, but I have taught it to you. So you should actually be able to do all of these, to tell you the truth. Yeah, you should be able to because because I've shown you. So it's a good thing I did teach it at the beginning because now we're pretty much done. 152. This is on your lesson plan thing I gave you earlier, but I'm just writing it down so you can see it. There it is right there. You should be able to do all of them, okay?
Oh, wait, it's only triangles.
So it's section 4.1. It's 1 to 16.